So now that we're done with all of our features, it's tempting to move on to the characteristics and create them right now. However, I've found that at least teaching this at STCC, we really want to make maximum utilization of our machines, and we can actually create characteristics offline. So if students have the software on their home computer, or if they want to work on the software outside of class time, you can actually build characteristics out without even having the machine. But what's really important is to make sure that we're driving through all of our coordinates and points without hitting anything. So we'll come over to the Features tab, and we are going to click on the top feature, that's Plane 1. We're going to hold Shift on the keyboard and left-click on the bottom feature. Notice that all of our features have been highlighted in pink, and for points it shows you the arrow of which way you're approaching in yellow. So that's how we know what we're going to run. We get some visual feedback there. And we'll come down here to the Run window. Here's a good default. If you don't know what you're doing, click Clear Existing Results first, and you do have to do that first because some things are not available in the selection heading if Clear Existing Results is off, right? Like right now it's off and I can't hit the pull down. If you clear existing results, I now have the option of doing a manual alignment. So there will be a more detailed video later that talks about manual alignment, current alignment, and measurement plan 1, which we would call the quote-unquote named alignment. But for right now, the simplest way to make sure you don't crash the machine is to always do a manual alignment. Now you'll learn as you get more knowledgeable later and you get more experience that manual alignment can cause you to have to touch a lot of points on the part that really is not necessary because the machine already knows where the part is. But to keep this simple, let's just say your default is going to be manual alignment, and the only thing you lose is time. We're going to always select current selection. That is important. So clear existing results, manual alignment, current selection, and then on the order of run, we'll go Features List, use Clearance Plane, slow through first feature, and in the speed, we are going to highlight that and type in 5.5 or 55 millimeters per second. All right, we're also going to slow the speed dial down. So in the real world, I grab the speed dial right here, slow that all the way down. I'm going to slowly open this up as we start measuring. All right, I'll hit Start on the computer screen, and the first thing that this prompts me to do is the manual alignment. So because of what we selected in the last window, manual alignment shows up as, or the manual alignment window shows up, and it tells us that we're going to take 3 points total, and so far we have taken 0 points. We're looking to touch plane number 1, so we see our first point is over here, and we'll go touch that in the real world. Now I go to move the joystick, and the probe is not moving at all. And the reason is I have the speed dial all the way down. So I'll open the speed dial all the way up, and then I'll come and take my first point. On the computer screen, notice that we have 1 actual point so far. It updates the graphic to show us where our next point should be. We'll come touch that. And these don't have to be exactly perfect, but they want to be on the top surface, and they want to be spread out pretty much as wide as they can go on the part. So we'll come touch point number 3, and now the manual alignment window updates so that it says 2D line 1, and we now want to touch 2 points on the front line. So there's point number 1, the graphic updates. We'll come over and touch point number 2. And the manual alignment window changes again. We are now looking for 1 point on the left side of the part. So you'll notice that this is replicating the automatic alignment or base alignment that we set up when we initially programmed the part. Now, right now, this says canceled, base alignment cannot be computed, and we have a red stoplight window. I think this traces back to when I opened up our base alignment, and I was just showing you, you got to be real careful about modifying these axes here. I was trying to show you as if this base alignment had been rotated, and that caused that to be not able to be computed. Right? But typically, as soon as you're done with your manual alignment, it will just go and measure your part automatically. So I'm going to pause the video and get back up to that spot. All right, so now that I've updated that base alignment, I went and redid the manual alignment, and now it says, caution, CMM being changed to CNC mode. Please move stylus system clear. So at this point, we want to take our speed dial and slow that all the way down. This is really important here. We're going to slowly open that back up like it's a faucet as we say OK. So I hit OK, and I don't see the probe moving here, so I'm going to slowly open this back up, and you can see the probe takes off pretty quickly, and I've only opened up the speed dial maybe 5 or 10 degrees, so it moves fast, and that's why you always want to have it closed at the beginning and end of any feature to make sure that you're not going to hit something. Now right here, I got nervous. We're getting pretty close to the clamp. From where the video is shooting, you kind of can't tell if we're going to hit the clamp or not. If you look from this side, you can see we have plenty of clearance. My point is, you can slow this speed dial all the way down and it will interrupt the execution in live time. So the whole time this is running, you want your hand on that speed dial. I'll slowly open that back up, and we can see that the machine does safely move to the next coordinate. Now, at any point, if you get nervous, slow that speed dial all the way down, and it really only takes effect kind of in the last like 5 degrees or so of closing it down, that it slows it down, but you can slow it down as much as you want. All right, notice that the probe is moving in kind of a weird way, moving around the back of the part. Now, if we had other clamps hanging out here, that potentially could create an issue. So I'm going to show you how to edit the feature settings editor to make sure that we're not moving around the outsides of the part. Really, for a two-dimensional part like this, where we're just moving around the X and the Y plane, the XY plane, we really want all of our clearances to be straight up and down, and by moving to the outsides of the part, we could actually end up causing problems for ourselves. So it looks like that entire program ran with no problems. That's great. So now we can, I'll segment the video here, and we'll talk about fixing our clearance planes next, and then we'll talk about how to build some characteristics. The important thing is, we started with the CMM tab, and the measurement tab, we jumped over to features, we built out all our features, and then we ran them to make sure that they run correctly before we do the characteristics. That allows us optimum use of the machine in terms of lab